All right, welcome back to Lag Demon Programming. I'm Bill Westlake, and we're working on compiler design. Last week, when we were working with this, we ran into an error, and it had to do with this character assignment here of this character constant in single quotes. And if I run this here, we see we get this error on line 12, or on column 12, line 15, and that is right... line 15, column 12 is right here where it's not picking up this quote correctly. And yeah, there's definitely a reason for that. And I figured it out, and I'm going to fix it right now. The typographical error that I made is right here. This is a slant quote followed by a quote. That's got to be a single quote there. And down here, when we want to stop and go back, it also has to be a single quote. But also, a little mistake here. We want this not to be a pin buff string, but rather char. And YY text sub-0 when it actually finds a character. And finally, this in here has to be not a single quote. It can be a single quote, but it's got to be a escaped single quote. Double quotes are fine. Now see, I got the double quotes again. So an escaped single quote is fine, and we'll test those in some of these, a few of them anyway, in here in a moment. Let's make, and let's run it. And now it looks like it compiled everything, and there's our A. Assigned to char, and there's no errors, and that worked perfectly. So let's go into our test.fng and create a few more character assignments here. And you know, we're not checking variable names right at the moment, but what I could do is just make this we'll do this appropriately like this, and let's make this let's give it a double quote and maybe a backslant N and a backslant T, and let me check over here. I believe we could do some hex numbers. Yeah, we can have a slant followed by any hex value. So let's put backslant 077. And what else can we do here? We can do slant R and slant V. So let's do slant R, backslant V, and finally, which one do we want to do? Did we do a backslant single quote? We got a double quote. Let's do a backslant with a single quote within there. And see if that compiles. It looks like it did. It looks like it reproduced all those. Now, so there's the double quote. It got that correctly. Now, we can't see some of these because we're printing out the literals. We probably should change at least the character constant one to print out. And that would be in our prettyprint.h. And it's going to be under parameter R value node, and an R value node is going to turn into a value character node, and we're doing just the C out to the get value. First of all, let's do it like this. Let's go quote, single quote, and quote, and a single, and a in quotes. Darn it. Double quote, single quote in between. But also, let's create a little function here, and we will call it re-escape the get value. And we'll just put that function, we'll just make it a function. And so we'll put it up here at the top, outside the class, and we'll go character, re-escape, character, C. And what's this going to do? Well, it's going to do a switch C. And it's going to go case slant n colon O. Standard string. Sorry. It's got to return a string, and the string it's going to return is going to be a literal slant n. And it's going to return that. So we can do case quote slant t colon return quote t, and the same with slant v. We have to do all of them, and I will do all those, but I want to catch the ones that we're doing in our code. We got missing semicolons. All right, and here what we will do is just return make that. Yeah, didn't like that. What didn't it like? Why doesn't it like return standard string C? Oh, because it's a... Okay. Return... we can't just return C. I wonder why. I know. Duh. Okay, we'll just go standard string result, and we'll go result dot append C, and then return result. Doesn't like that either. See. Okay. What do you know? Now when we run it, at least some of these should be there. So slant V it picked up, slant T it picked up, slant N it picked up, and we can do the rest of them. I'll do those separately. I won't bore you with a whole bunch of typing, but you can see how we can re-escape them, and it shows what's actually in the value. But that's not changing the value, it's just doing it for printout purposes. It's still containing the actual value that was put in there. Okay, good. Now, moving on. We've got that fixed, more or less. I'm going to get rid of the Lexer for the moment. So, what do we need to do? Well, let's bring up our parser real quick. We've got some really good stuff going on so far. We've got a really good language going on. It's got some interesting capabilities, but it's missing a number of important data structures, and we need to include those in there. 1 second, I'm going to pause the video for just a second. Okay, I'm back. But we're missing some important data structures, so we're going to take a look at how we can compose those. We have this R value list here, or R value and R value list here, but we need a couple of different kinds of lists of R values, and one of those is going to be something that's comma separated list of R values, and the reason for that is the way we're going to do some data structures, and we also need one separated by semicolons. So the first thing we're going to do is call this data R R value list. And this is going to be an R value, or it's going to be a data R value list followed by an R value list already has a comma separated. Well, I'm going to keep these separate. Well, actually, yeah, comma followed by an R value. I'm going to keep these separate, two separate concepts, because we do have to put them into a little bit different node, I think, for what we're going to do. So the first data structure that I want to talk about that uses this data R value list is the tuple. So a tuple is sort of like a record, except the values aren't named. It's their position that makes the difference, and the values can be of any type. They can be of any R value type, which we're going to find out very soon that an R value since an R value is an expression, one of the types that can also be, that an R value can be, is in fact this tuple type that we're going to create. So let's say what a tuple is. A tuple is going to be an O parent followed by a data R value list followed by a C parent. Now technically this data R, I know why I was going to do separate ones. Let's add something else in here. Technically a tuple, in fact I'm going to call this a tuple R value list. A tuple, it doesn't make any sense to have only one field in a tuple. It's got to have at least two or more. So what we're going to do is we're going to create a thing here called a tuple pair. And a tuple pair is going to be simply an R value followed by a comma followed by an R value. And then instead of being an R value here, it's going to be a tuple pair, or that followed by an R value. So it's got to start off as at least a tuple pair and then becomes an R value as it moves through. And that actually forms then a tuple, an open parent. This now has to be a tuple R value list followed by a closed parent. So for a tuple pair or a tuple R value list, we can create the same kind of R value list that we created here. So a tuple pair and a tuple R value list have to be the same thing as an R value list. So let's come up here, and we've got the R value list type. So let's create our type. We've got R value list right here. So this can be tuple pair and tuple R value list, or of those types. So let's go down and fill those in. So a tuple pair, we're going to just do the same thing up here, except we're going to have to push back both of them. So let's grab all of this. Oops. Right here. So here's the pair. Put that in, and we'll push back $1, and we'll go $, pointer, push back $3. Okay. So far so good. And if we've got a tuple pair, that obviously came from here, so we can just go here and go that $, pointer, push back $1. Or it's going to be $, equals $1, followed by $, push back $3. And then we have a tuple. And a tuple is going to have to be a data type over here. So let's open up our AST, Fungin AST.cpp. I wanted AST.h. Let's reverse those. And so let's come down. Well, a tuple is something that can be involved in other things. So it needs to be up high, but it also has to be able to have, yeah, this is where it gets, this is where it gets a little bit complicated, and I probably should have put these implementations in this CPP file, but we'll do this. Let me figure out the best place to put this. It's going to need to, things are going to be able to need to use it, an identifier. It's a kind of, in the form we've got, well, it's an R values, so it's going to have to deal with R values. Okay, so we're going to put it right here, right after these literals. Okay, so we're going to go public. No, excuse me. We're going to go class, and we're going to call this tuple. I'm not putting node after the end of these. Parameter, function call. No, I'm not. Okay. Tuple is public, and it's really an R. A tuple is an R value. Okay. So then we need to have a protected, and it's going to be similar to, so we've got an R value list, so we need an R value list pointer, R values. Yep, that's it. Public tuple. We'll take an R value list pointer, R values, colon, oops, colon, underscore R values, R values. Ah, darn it. And then we need to get those, so we need R value list pointer get R values return underscore R values, and then we need this accept method, and we need to do the implementation of that accept method down here, and it doesn't matter, we'll go void. It's going to be tuple colon colon accept and then we're going to have visitor pointer visit this. Okay. We have our tuple set up, then we go back to our parser, and here where we've captured a tuple finally, we're going to go $$ equals new tuple, and it's going to be $2. Simple as that. Now, where does a tuple fit in our scheme? Well, it is another kind of R value. So we can just go that it's a tuple, in which case we can say that $$ equals $1 when an R value is a tuple. We can do a make, and like something. R value list has no declared type. Yes, it does. R value list, tuple value list. R value list. What do you mean R value list has no declared type? Okay, data R value list has no declared type. Oh, that's because I changed it to tuple. And now we're down to R value list has no declared type. Yes, it does. R value list, a tuple, is an R value. I put that in the wrong place, didn't I? X, L value, R value is an R value, an expression, or an R value like that, or it's a tuple. An R value can be a tuple. $1 of R value. Tuple. Oh, I didn't define tuple. Okay, so we have to go up here. We gotta remember to do this. So tuple, pointer, tuple. And then down here, always gotta remember these. Percent type, tuple, tuple, tuple. And what doesn't it like now? No matching function call for R value pushback R value list. Tuple pair is an R value list. Sorry. $$ equals $1. R value has no member name push underscore back. And what do you know? Now we can go to our little test script. What's this? Untitled one. I don't know what that is. Test.fng, and we can do something like let A equal in parentheses 1 comma 2 comma quote A quote comma this is a string a tuple 42.5. It looks like it compiled it all. Let R equal, where did I put it? Let, this is a string. Oh, you know what? We didn't pretty print that, so it didn't know how to do it. So now we need to go to prettyprint.h, and we need to have, we'll just go down here to the bottom. No, where did I put it? Right after, somewhere right after R value, right? Yeah, we'll put it here. Virtual void visit tuple pointer node override, and we're going to need this to put in visitor.h, and There's R value. No, we don't have an R value in here. That's right. Well, oh yeah, there it is. Equals 0. We'll start with make. Make sure that works. Okay, now pretty print dot h. We need to do standard cout from an open parentheses, and we will need standard cout from close parentheses, and then we will need to go for auto and colon node pointer get R values and pointer visit this. Oh no, accept this. And pointer accept this. Pointer and quote quote, this is a string, a tuple 42.5 tuple pointer node. Why didn't it get called properly? Okay, well, we're almost there with getting our tuples working. I'm pretty sure they're working because this stuff is coming through. There's just something not happening with this properly. This doesn't even look like it's being called for some reason. Visit tuple pointer node override visitor. Oh, I think I know why. Because we also have to add it into, no, this is pretty print.h. This is pretty print.h, okay, and it's visitor this doesn't look like it's being called. Huh. Okay, well, I'll figure this out before the next video, and we'll fix it, but I think we're pretty close. We're at about 28 minutes here, so I think this is going to be the end of this video. Thanks for watching. I hope you liked it. If you really liked it, hit that like button, and if you want to subscribe, please do. I appreciate subscriptions, and I will see you in the next video. Thanks for watching.